Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This video and the others in the Chapter 3 Problem Solving with Python playlist are an introduction to the concepts you will need to write programs with branching or if statements. This video accompanies Problem Solving with Python Chapter 3, but it's okay if you don't have the book. The videos stand alone as instruction on these topics. In the last video, we talked about variations on the if statement that allow you to solve problems that require more than a single branch. So if, elif, else in several different combinations, and nested if statements. In this video, we're going to talk about the Boolean operators and or, and we'll talk about how to check that a value is inside or outside of a range. Let's dive in. In a prior video, we learned about Boolean expressions. Boolean expressions evaluate to true or false and are used in logic that controls the flow of our programs. We use if statements to create branches in our programs. If statements test a Boolean expression that evaluates to true or false. We created these expressions by comparing variables, literals, and arithmetic expressions with the relational operators less than or equal to, greater than or equal to, and not equal to. We can create more complicated Boolean expressions using three more operators, and, or, and not. These are called the logical operators. Let's begin with and or. The and or operators create more complicated Boolean expressions by combining two Boolean expressions. And we do something like this in natural language. So let's begin with a natural language example and then formalize our definitions. Let's start with and. Suppose your mom says to you, you can go to the beach today if you clean your room and you unload the dishwasher. From our understanding of natural language, we know that we are only going to go to the beach if we do both chores, clean our room and unload the dishwasher. Doing only one chore, or doing neither chore, will mean we do not go to the beach. The and expression in Python and other programming languages works that way. As I said, and or create more complicated Boolean expressions by combining two Boolean expressions. And combines two Boolean expressions, and the full expression evaluates to true only if both Boolean expressions are true. In all other circumstances, and comes out to false. So if one expression is room is clean, and the other is dishwasher is empty, they both have to be true for the whole expression to be true. If either or both are false, the whole expression is false. We can express this formally in a truth table. Because an and combines two expressions that can only evaluate to true or false, there are only four possible combinations of operands to an and. We show these in a table. We'll call the operands A and B, and then the result is A and B. In Python, the and operator is actually the word and, all lowercase. So the four combinations are true, 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 false, false, true, and false, false. Like flipping two coins, heads, 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 tails, tails, heads, tails, tails. Okay, and the A and B column is true for true and true, but it's false for all other combinations. That's when we don't go to the beach. We'll look at this in a program in a moment, but let's cover how or works first. We'll start again with a natural language example. You're watching your little sister today, and you know you can make her very happy if you buy her a treat when the ice cream truck comes around, or if you take her to the park to play with her friends. She'll also be happy if you do both. The only way she won't be happy is if you do neither of these things. That's how an or works. The expression will evaluate to true if either operand is true or if both are true. The only way it comes out to false is if both are false. And here is a truth table of or that shows that. Again, we have two columns, A and B, for the two operands, and they have the values true, 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 false, false, true, false, false. And in the A or B column, all results are true except for false, false. So let's look at an example of these in a program, and then we'll see how they're used to check whether a value falls inside a range or outside a range. Let's write a program that uses our two natural language examples. We'll ask the user a series of questions. I'll begin with a docstring at the top, so 3 quotes, demonstrate and or, and another 3 quotes. Then I'll annotate variables to store the user's answers to our questions. So I'll comment annotate variables, and I'll annotate 2 strings, clean room and empty dishes, and 1 integer, num ice cream, and 1 float, hours at park. And let's do these one at a time. So we'll do the and question first. I'll write a comment, ask the user whether they've completed their chores, and then I'll write 2 prompts and store the results in our variables. So clean room equals input, did you clean your room? Yes, no. And empty dishes equals input, did you empty the dishwasher? Yes, no. And then a blank line, and then a comment. If they both cleaned their room and emptied the dishwasher, they can go to the beach. So here's where we'll use our and we're going to expect that the user has typed yes, all lowercase, at the prompts. And if they typed anything else, we're going to consider it a no. So I'll write if clean room equals yes, and empty dishes equals yes, and a colon, and then print you may go to the beach. And else colon, print you must finish your chores if you want to go to the beach. So it's the same structure of an if-else statement that you've learned in the past, but the condition is a compound condition, one that uses an and, rather than simply the relational operators. Please notice that we have a complete condition with a relational operator that evaluates to true or false on the left of the and we have a complete condition with a relational operator that evaluates to true or false on the right of the and. Remember that and takes 2 operands. Each one evaluates to true or false. So we need a complete expression on each side that evaluates to true or false for this to work. Now, in this case, we've used equals because we're comparing for an exact match to the string yes. But we can have any expression that evaluates to true or false, including a compound expression with an and or an or. I would recommend not making your expression super complicated, though. You want to ensure that your program is readable. Now, how many times would we have to run this to test it thoroughly and to demonstrate how the and statement works? Our and statement will evaluate to true if we enter yes at both prompts. And if we enter anything else at either prompt, it will evaluate to false. So we can test the 4 combinations, yes, 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 something else yes, and something else. I'm going to type no for something else, but remember that any input other than yes is going to count as not yes, or basically no. So we'll run it, and yes, and it tells us we can go to the beach. I'll run it again, and yes, no, and we must finish our chores. Run it again with no, yes, we must finish our chores, and one more time with no, we must finish our chores. Now, I'm going to select everything from ask the user whether they completed their chores through the end of our else and comment it out by choosing Format, Comment Out Region. So this code won't run when we work on the OR code. Let's write the OR example. So I'll prompt the user for num ice cream with how many ice creams did you buy your sister, and cast the result to an int. And I'll prompt the user for hours at park with how many hours did you spend at the park, and cast the result to a float. And then we'll write the if statement. If num ice cream is greater than 0, or hours at park greater than, let's say 0.5, so at least a half hour, colon. And we'll print your sister's very happy. and else colon will print your sister is bored. Now remember the 4 combinations of inputs, true, 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 false, false, true, false, false, and predict the outcome for each. We should be able to get the happy message if we enter a value greater than 0 for ice cream, if we enter a value for hours at park greater than 0.5, or both, and if we enter a number 0 or lower for ice cream, and we enter a number 0.5 or less for hours at park, we get the bored message. I'll leave it for you to confirm that the OR expression does work that way. I want to just briefly mention a way people sometimes write and or expressions that is incorrect, and that is to not put a complete expression on either side of the and or. So, for example, a person might write, if answer equals yes, all lowercase, or yes, all uppercase. Or with the and example, if clean room and empty dishes equals yes. Those are natural ways to talk, but they don't work for programming logic. Both of those expressions will compile, and I do have a video that goes into detail on what those actually mean, which I will link here and in the description. Briefly, many programming languages evaluate any non-zero, non-none value as true, and any 0 or none value as false. So because we need a complete expression on either side of an and or an or, in the first example, answer equals yes is a complete expression, and on the other side of the or, we have yes. Because that's not 0 or none, that will evaluate to true. That means this expression will always evaluate to true. I'll show you. In the console, I'll assign the string no to answer. And now I'll write, if answer equals yes or yes, print, why did that work? And when I press enter, the console prints, why did that work? Because the expression evaluated to true. Now, you might expect that to evaluate to false, because answer is neither yes nor yes, but you can see it evaluates to true for the reasons I described above. If that is confusing right now, don't worry. Just remember to always put a complete expression on either side of an and an or. Put a pin in it, and come back later when you've had more experience programming and see if it makes sense. You can also watch my other video for a more detailed discussion. For practice, see if you can figure out under what conditions the and expression will evaluate to true and false, and test your theory in the console. Okay, now let's turn to a number line and the subject of checking for a value within a range and checking for a value outside of a range. There are a lot of reasons we might want to do this. For example, we might want to know if a person is eligible to sign up for a particular service or job. For example, if you want to enlist in the Coast Guard, you have to be between 17 and 31. Suppose you are going to put your dog outside if the temperature is between 40 and 70 degrees. Or imagine if you're checking if a person was born in the 1980s. In all these cases, you want to know if a value, age, temperature, or year of birth falls within a range, 17 to 28, 40 to 70, or 1980 to 1989. You also need to know how you're going to handle the endpoints of the range. Are they included or excluded? So can a 28-year-old enlist in the Coast Guard? Will you put your dog outside if it's 70 degrees or only up to 70 degrees? To check for a value within a range, we can check that the variable is greater than or equal to the lower end, and also less than or equal to the higher end. Whether we choose less than or greater than versus less than or equal to or greater than or equal to depends on whether we're excluding or including the endpoints. Let's do an example. We'll do the 1980s example. In this case, we'll include the endpoints. And on the number line, I'll draw filled circles over 1980 and 1989 and the line between. This indicates the endpoints are included, and we want to test for a value within that range. And if our variable is called year of birth, we write year of birth greater than or equal to 1980 and year of birth less than or equal to 1989. The first expression would include values like 1990, 2000, 2020, etc. And the second expression would include values like 1900 and 1950. But if we AND them together, then the variable has to pass both tests, both greater than or equal to 1980 and less than or equal to 1989. So the expression will only evaluate to true for values that are within the range. Now suppose we want to test for a value outside of the range. We'll use the same range. If we want to know if somebody was not born in the 1980s, then they might have been born before 1980, or they might have been born after 1989. They can't be both. So either less than 1980 or greater than 1989. Let's write that out. Year of birth less than 1980 or year of birth greater than 1989. So this expression will evaluate to true for a person born in 1950 or 1979, for example, and it will evaluate to true for a person born in 1995. But it will evaluate to false for a person born within the range 1980, 1981, etc., up through 1989. Remember, you choose AND for testing a value within a range, and OR for testing a value outside of a range. Remember, you use less than or equal to and greater than or equal to when you want to include an endpoint, and you use less than and greater than when you want to exclude an endpoint. Now, just one more quick topic in this video. Because we've introduced two new operators, AND and OR, we should take a look at the operator precedence table in Python to see where they fall. So here's the table from python.org, and we can see our familiar arithmetic operators at the top: exponentiation, the multiplication operators, the addition operators, and then we see our familiar relational operators below those, and then below those are AND and OR. Notice that AND has a higher precedence than OR. So these are not evaluated left to right in an expression. If you have an expression with both an AND and an OR, the AND will be evaluated first. And this does make sense. It means that if you use relational operators in the expressions that are the operands to an AND and an OR, like we've been doing all along, we've used tests for equality and less than and greater than or equal to, those are evaluated first. And then the results become the operands to the AND or the OR. Remember that order of operations is important so we're consistent. There isn't a mathematical justification for the order, and now that we're looking at operations that are programming operations and not mathematical operations, the order of operations will vary from language to language. But it's important that we're consistent within mathematics and within a language, so you get the same answer that I get, and we both get the same answer that Python gives. And remember, we can always force an order with parentheses, and we can clarify an order with parentheses. If you are writing a very complicated expression, you might consider breaking it up into separate steps to make it easier to read, modify, and understand. I'm going to end this video here, and I urge you to experiment with this. Try retyping the programs in this video from scratch without looking at them, and see if you can get them syntactically and semantically correct. Practice with AND and OR until you can always predict the outcome of an expression, and practice checking for values within and outside of ranges. I've included some auto-graded exercises in the description of this video so you can practice with the video code. Once you've mastered the concepts here, you're ready to move on.